So this is question 17 from 3.2. A couple different ways to work through this problem. All right. As far as the shortcut working with trinomial expansion using the special product forms, I would limit that to the sum and difference of terms unless you're very comfortable working with the different patterns. Okay, so there's two ways to approach this. Okay, if you are comfortable with the pattern that we have is quantity a plus b squared, okay, where a is a binomial, x minus 3, b is just the y. Okay? And so if you were to expand this out, a binomial square expands into the first term squared plus double the product of the terms plus the last term squared. Okay, so if you write this all out, or if you mentally create this pattern, you can then just fill in the blanks here. So a is representing our binomial x minus 3 squared plus 2 times x minus 3 substitutes in for a, and y substitutes in for b, plus b squared, which is y. So you can substitute those in and then continue to simplify. We have another binomial square expansion. So we square the first term x, double the product of the term. So x times a negative 3 is negative 3x. Double that, you get negative 6x. Square the last term, plus 9. Here, if we move our y over, again, just reorganizing our factors, and then distribute, we get a plus 2xy minus a 6y, and then our last term, y squared. So if you're going to rearrange these in the order that I asked you to write, so by degree first and then alphabetical order second, we have our second degree terms, which are x squared, 2xy, and y squared. So we'll write those in alphabetical order. Then we move to our first degree terms, which is the negative 6x and the negative 6y. And then we can move to our constants, which is just a plus 9. And so that's how we would get our solution if you're going to use the pattern, the expansion rules for binomial square. And now, if that causes you problems, meaning especially if you forget, if you're continuously forgetting this product of 2ab in here, or it just doesn't make sense, with a binomial square written with the 3 terms, you can just extend this out, represent your square by just rewriting the multiplication of the same 2 factors, x minus 3 plus y, and you can get rid of the grouping symbols. You don't need those there. And then just distribute. So if we start here, we get an x squared minus 3x plus xy. Move to the next term, minus 3x plus 9 minus 3y. Move to the last term, distribute it, plus xy minus 3y plus y squared. And then just combine straight down your columns. And what you see here is, and then just reorganize your terms in the same way. We get x squared plus 2xy plus y squared minus 6x minus 6y plus 9